Okay, we are now going to get started with talking about identifying bumblebees in the Pacific Northwest. And some of this is really going to be focused on these 4 primary species that we're looking for. So I want to make sure that you all know the basics of how to identify those 4 species, but also what photographs are the best ones to take. And so, you know, while this will be a sort of brief introduction to bumblebee taxonomy and a little bit about how to identify these animals, this is a lifelong passion, right? It's not easy to become an expert in bumblebee identification. And I don't expect you all to become bumblebee identification experts in the course of a, 40-minute or half-hour presentation on how to do this. And so I don't need you to be bumblebee experts. I don't need you to know how to identify every species that you see. I'm thrilled that you're curious in it, and I'm happy to help guide you in that along the way. But the purpose of this is largely just for your information. And the best thing that you can really do is contribute photographs to this project. And I think I've talked pretty clearly at this point about how important that is and how significant that is in terms of making positive contributions towards this project. I think something like around 10% of the photos that were submitted or the observations that were submitted in the first iteration of this project were unidentifiable from photographs. And some of that was because they were males, but others were because just the photo quality wasn't quite good enough for me, at least, to identify them. It doesn't mean someone else couldn't have done it, but I wasn't able to. And so, that's 200 and some odd observations that, we weren't able to get the information that was available if better photos had been taken. So, hopefully that's not a lot of information lost, but it's certainly some information lost, and we'd like to reduce that number if we possibly can. So here we go, photography and ID tips. Some of this is going to start as just kind of a flow chart of how to think about identifying sort of a bumblebee from other animals that you might see when you're out on the landscape doing some of this work. An important thing to consider as you get started is, as we've talked about from their life cycle, there are different castes of bumblebees. There are males, there are workers, and there are queens. And all of these are out on the landscape at different times of year. And more importantly, for our purposes that we're talking about right now, all of these animals often, or all of these castes often look different from each other as well. So workers and queens almost always look different than males. And sometimes workers look different than queens. And this can make identification quite challenging as you try to think about variations and differences. So there's, in addition to color pattern differences, there are also size differences. So there's a huge variation in worker size, and there's also a huge variation in male size, even within a species and even within a single colony. The first sort of brood of workers that come out are often very, very small. And then later in the season, those workers can be much bigger and more robust. So lots of differences here to consider as we think about surveying for bumblebees. This is a flow chart that I've developed over the years for sort of identifying an animal or seeing an animal on a flower and trying to figure out whether it's a bumblebee and what species it is. And so the first question really that you need to ask yourself, is it a bee or is it not a bee? And so there are a lot of what we call wannabes out there that look a lot like bumblebees, but aren't. So I'm going to launch another poll question here, and I'm going to ask you to try to determine which of the species or which of the animals that you see on this chart are bumblebees, or is a bee of any sort, actually, not just even a bumblebee, but which of these are bees? And you can select multiple. If you think that multiple of them are, you can select multiple. So which of these are bees? It's okay if you're wrong. Nobody's getting graded. This is just to illustrate a point. That's all. A few more answers still trickling in here. I'm going to shut down polling in just a couple minutes, in a few seconds here. So try to get those answers in if you can. So this is very interesting to see. I'll share these with you in 10 seconds. I'll stop. Still answers coming in. Okay. So at least one of you thought that every single animal on this page was a bee. And in fact, there's only one bee on this whole page. And there was a tie between the two most animals that you all thought was most likely to be, and that was A and F. And half of those people were right. It was F. So F is actually the only animal on this page that is a bee. The rest of those animals are all flies, and they all look like bees for a good reason, in that it's just something called mimicry. And so flies don't sting, but bees do. And so because bees sting, they're less likely to get eaten by a bird than, say, something that doesn't sting. And so if you're a fly that doesn't look, that looks like a bee, then a bird might be less likely to try to eat you if it was afraid you were going to sting it on the tongue or somewhere on its body while it was trying to eat you. And so this mimicry provides protection for animals that aren't bees. And so every single other one on this page are actually are flies. And I can see why some of you were probably fooled by A. You were probably thought this might have been an antennae right here. And so you thought, oh, it's got long linear antennae, for those of you that are informed. And I know it's hard to see on a small screen, but that's actually one of its legs sticking out there. It's sort of grooming itself and sticking one of its legs out there. So that's its leg and not its antennae, if you're sort of curious as to why that's not a bee. So I'm just going to go through quickly, like, how can we tell a fly from a bee? Some of the things that we can look at. One of the things that we look at is the number of wings. So how many wings does a fly have versus a bee? Bees have 2 pairs of wings, and flies only have 1 pair of wings. They actually have 2 pairs of wings, but 2 of them are vestigial back here. So they have 4 wings, but they have these tiny little wings that aren't developed anymore. But bees, you can see this bee here has a hind wing and a forewing on each side. It's a little hard to see, but if you look closely enough, or maybe if you squint, or maybe you just trust me about this, that there are actually 4 wings there for that bee. Another factor is that, as I mentioned earlier, one of the unique things about bees that make them such good pollinators is they carry pollen through the landscape. So a lot of bees would have pollen on their legs or somewhere on their bodies, and no flies are going to have that many pollen grains on their bodies. So carrying pollen is another thing to look for. Bees are also almost always universally hairy all over their bodies. At least bumblebees are, and that's not true of most flies. Most flies are fairly hairless, and they often have colored exoskeletons, whereas bumblebees are going to have colored hairs on their bodies. And then antennae is another really good one to look at. Our bumblebees and other bees are going to have long linear antennae, and our flies are going to have short stubby antennae, or sometimes feathery antennae, but not long and linear. And the final thing to look at here are the eyes. Generally, bees are going to have their eyes on the side of their heads, and flies have these large bulging eyes near the front of their heads. So these are all things that we can look at. Another thing that's not listed here are just looking at the legs. Flies tend to have these real skinny, what I call chicken legs, whereas bees have sort of much more robust structures for grooming and carrying pollen around. Another animal you might mistake for a bee probably not so much a bumblebee, but a bee is a wasp. But most wasps are going to look very different from bumblebees, and you're not going to find yourself confused in this way. But wasps are very closely related to bees. They're in the same order, and they also have 4 wings or 2 pairs of wings. But unlike bees, they don't carry pollen. They're not very hairy. They have these colored exoskeletons, and they also tend to have these skinny waists. And in comparison, bees are going to have rounder bodies, and they're going to carry pollen. They're usually hairy, or at least somewhere on their body, and they have their eyes on the side of their head. And so that's kind of this first decision tree of, is it a bee or is it not a bee? I think those are the 2 main animals. In terms of identifying, now we sort of move on, and we need to decide if it's a bumblebee or some other bee. And sort of there's two main species of bees that or groups of bees that you may mistake bumblebees for. One of them are honeybees, and mostly just because they're abundant, and some of the more common bees that you'll see in some areas. But realistically, they're quite different. They actually, kind of like wasps and flies, have colored exoskeleton. So that brown and black patterning that you see is actually on their exoskeleton and not hairs. They have these torpedo, sort of long linear shaped abdomens, and they're sort of these paler colors. Whereas our bumblebees are going to be sort of big and bold and more hairy and more robust than honeybees for the most part. Another group of animals that you may mistake bumblebees for or mistake for a bumblebee are carpenter bees. And these, we won't find these throughout our region, but they are found in as far north as the southern Willamette Valley in Oregon, and we find them in southern Idaho. So they are around. And one of the ways to tell a bumblebee versus a carpenter bee is by looking at the abdomen. Carpenter bees are kind of warm weather specialist bees. They have their highest diversity in the tropics and warmer areas. So they're structured to regulate their temperature in warmer temperatures. So their abdomens are not hairy. They're usually quite shiny and reflective. So you see the sun reflecting off of them. And you can see that in this photo on the left here of a carpenter bee, where there's no hairs on that abdomen, whereas the bumblebee on the right is fully and universally hairy throughout that. Carpenter bees also have scopa, like we talked about at the very beginning of today. They don't have a corbicula, so they're even though these animals are in the same family, carpenter bees have these hairy scopa and not the hairless corbicula that we talked about. And so carpenter bees carry their pollen dry. They don't mix it with nectar. So you can see that cake on the bee on the right there, where the pollen on the bumblebee on the right, where the pollen's been mixed with nectar and it looks kind of wet. And if we saw that on a carpenter bee, it would be much more powdery and dry and not wet like that, which would be another indicator. Once we've got to bumblebee, then we need to think about, do I have a male bumblebee or do I have a female bumblebee? And to do that, we're going to look at different anatomical features. We're going to look at antennae. We're going to look at the legs and whether it has a pollen basket or not. And then we're also going to look at the abdomen and the shape and length of the abdomen, as well as the overall features of the bee. So there's just some general characteristics that male bees have versus female bees. And one of them is that female bees appear to be what we call very well groomed. And this is because they are. Bees, as we've mentioned, are constantly covering their bodies in pollen. And female bees are the ones that do this. Male bees actually don't collect pollen, and they don't, so they're not going through this process. Whereas female bees are putting pollen all over their bodies, and then they're combing that pollen off of their bodies to put into their hind legs to bring home to bring to their young. And so that process of constantly sort of combing and moving their legs across their bodies does give them this sort of well-groomed, combed appearance, whereas the male bees don't do this. So their hairs appear sort of much more mangled and uncombed or unbrushed, because they are. And so just to give you some idea of what that looks like practically, here are a couple of female bees that their hair is even, and they look sort of like they're taking care of themselves. And then here you got this male bee that has sort of hair sticking up everywhere and no real order to it. In addition, male bumblebees don't have a pollen basket. I just told you they don't collect pollen. And so they've sort of lost that corbicula. And you can see this big triangular shaped corbicula on the female bee here to the left. And then this kind of just sort of oval general shape there with no corbicula. There might be a little hairless area in the middle there, but it's not going to look anything like this concave triangular thing that we have here on the left with the females. Female bees also have 6 abdominal segments, whereas the males actually have an extra abdominal segment, so 6 on the females and 7 on the males. And it also changes sort of the shape of the abdomen. It's longer and sort of skinnier, whereas the females tend to be sort of shorter and more robust. Males also have an additional antennal segment. So females have 10 what we call flagellomeres, which are after the bent part of the antennae there. And the males have 11 flagellomeres. And each of those flagellomeres also tends to be a little bit longer too. So male bumblebees sometimes have these very long antennae. They look like they sort of have long horns on them. And then some male bees also have extremely large bulbous eyes. You can see this on the right here. This particular species of bee has a very, very large eyes. This isn't true of all males, but it is true of some males. They start to look a little bit more like a fly than a bee. It's also worth noting here that you can see it at the bottom there that female bees have a stinger and male bees don't. The stinger is actually a modified ovipositor, so it's what they lay their eggs through, and males don't lay eggs, so they don't have a stinger. Now, I don't recommend that you use this as a way to determine whether it's a male or female in the field. It may lead to some tears or getting stung in the hand. So I don't use it as a identification feature necessarily, but it is true and something that's worth noting. And then once you get really good at it, you can use it as a party trick and grab male bees off of flowers with your hands. You'll impress all the kids. Okay, and then once we have male or female bee, then we need to determine whether we have a cuckoo bee or a psithyris, or we have one of the true bumblebees or non-psithyris bees. And to do this, we're going to look at the hind leg. Just like male bumblebees, the cuckoo bumblebees, as you remember, don't collect pollen. So their hind legs look very different. This is a male cuckoo bumblebee. So you can see it's got this skinny hind leg that has hairs all over it, universally hairy. And that leg is also convex. So it's basically rounded coming up out of that photo at you. And you compare that to a true male bumblebee, which has actually a little hairless area in the middle there. So it looks a little more like a corbicula, but it's not triangular like the female leg would be. But so again, we sort of compare the rounded, universally hairy cuckoo to the kind of flat and a little bit hairless male true bumblebee. Same thing with the females. Here's the cuckoo hind leg, which is again concave coming out of the picture at you and universally hairy. And we compare that to the corbicula, which has this big open triangular shape, and it's actually concave. So you could sort of pack pollen in there. So again, we'll compare the cuckoo hind leg to the true bumblebee hind leg. Sometimes that true bumblebee hind leg is going to be covered in pollen or filled with pollen. But in that case, you know it's a true bumblebee because cuckoo bumblebees don't collect pollen. So it's not something that you would see on them. So if it has pollen on its hind leg, it's a true bumblebee. Okay, so that's basically the flow chart. And now we need to start thinking about once you're there. So once you know you have, say, a female cuckoo or a female true bumblebee, then we can start looking at color patterns. And it's really important to go through that flow chart just because if you start If you're looking at a bee and you're looking for color patterns, just knowing whether it's a cuckoo or not separates a lot of different species out. And so it's really important to go through that process before you start looking at different color patterns. Sorry, I need to take a drink of water here. It's been a lot of talking. Hopefully a lot of good talking, but it's been a lot of talking. And so then when we start looking at color patterns, as I've mentioned earlier, we're going to look at color patterns on different parts of the body. We're going to look at the face, sort of at and below the wings. And then we're also going to look at the vertex, or the top of the head, or you may hear me call it the hat of the bumblebee. Then we're going to look at the thorax, which is where the wings and legs are attached. We're going to look at the banding pattern here. We'll look at what the hairs look like in front of the wings, what the hairs look like behind the wings, whether there's black hairs mixed in there or behind. And then we'll also look at the banding pattern on the tergal segments. So we'll look at T1 through T6. This just stands for tergal segment. So the segments on the back of a bee are called tergal segments, and they're numbered T1 through T6, one being closer to the head. And it's important to say, I guess, this point moving forward, all of these color patterns that I'm sharing with you are female bumblebees. Male bumblebees can be very difficult to identify from photographs. And so I'm not focusing on that today. It can be done. If you've looked at a lot of them, you can certainly do it, but there's so much variation. It's hard to share generalizations like it is with females. So I'm just skipping males and not talking about them. That doesn't mean that we don't want those data or your photographs, or that you shouldn't try to identify them yourselves. It just means that it's a little bit harder, and I'm not talking about it today. Another thing that really helps beyond color patterns is looking at the length of the cheek of a bee. And the cheek relates to the tongue length of the bee. The longer this space between the bottom of the eye and the mandibular hinges here, the longer the tongue of the bee. And so some bees have longer tongues and some bees have shorter tongues. You can see here that the space between the eye and these hinges is much shorter on Bombus occidentalis over here on the right than it is on Bombus fervidus over here on the left. We're lucky to have some authors that have put together tremendous resources for us to identify bumblebees. This wasn't true even just like 6 or 7 years ago. These are pretty new resources available to us. This book on the left is called Bumblebees of the Western United States, and it's limited to just species in the West, which is a nice feature of it. It's also kind of a spiral bound book, and you can download a copy of it for free, a PDF copy of it for free. But it is a little bit out of date. The taxonomy has changed. And this book on the right, Bumblebees of North America, for which I've referenced a few times earlier in this talk, and Leif Richardson, who's on this, is a co-author of this book. And it's sort of the authoritative book in North America. It's really a beautiful resource and very handy in terms of its descriptions and in its color pattern diagrams. And there's a whole lot of more information in there as well. But these are both great resources. I recommend both of them to you. Although the taxonomy that we use in these two books, we use the taxonomy that follows by taxonomy, I basically mean the names that are used in this book on the right, the Bumblebees of North America. The Bumblebees of the Western United States uses some different names for species than we use. And so there we go. That's sort of an introduction as to how we go about doing this. And now I'm just going to introduce you to these 4 species, what we're calling the big 4 and their lookalikes. So these are the 4 SGCN species. I'm going to just go through briefly how to identify these 4 species, as well as what their lookalikes look like. And I'm also going to talk about, if you think you may have encountered one of these species, what photos should you be sure to take and submit for these animals so that we can make sure that we've found that we can identify them to species. And so starting with Bombus morrisoni, again, this species has really unique coloring to it. It's a golden color that I've not seen in any other species of bee. And it doesn't come through in photographs probably well enough, but it's this really bright, vibrant color to it. In addition to that, Morrison's bumblebee has entirely yellow hairs everywhere on its thorax. So it doesn't have a spot or a stripe of black hairs. It just has on the top of its thorax, it's all yellow hairs, and that's unique for this species. It also has a yellow vertex, or the top of its head here is yellow. And its close lookalike species, which we'll go over in a minute here, has black on the top of its head and has a black spot in the middle of its thorax, or at least it usually does. So those are the two main things that we're going to look for. And so photos that include the top of the head and a top-down look at the thorax are going to be very important to identify this species. It's also good to get, so these are where we've encountered this species so far to date. So largely in southeastern Oregon and southern Idaho, but also a couple observations in Washington. But you should be looking for this species throughout the drier sagebrush steppe habitats in the Pacific Northwest. So throughout sort of central Washington and throughout much of eastern Oregon as well. We could potentially find this species. In addition to the top of the head and that thorax, this species also has a pretty short cheek. And so getting a photo like the one you see here that shows off that cheek length, here you can see, you may not be able to tell that this is a short cheek, but I'll show you a picture of its lookalike species in a couple minutes and you'll be able to tell the difference. So a picture that shows that cheek length and also the top of the head is another great photo to include with this species. And this is Bombus nevadensis. So this is not an SGCN, but this species looks a lot like Morrison's bumblebee. One of the main differences of this species is just the coloring. So this is more of a straw color than it is that bright, vibrant yellow. But in addition, this species has a black spot in the middle of its thorax, and you can see that in the photo here. And then also in its color pattern diagrams. And then it also has black on top of its head. So it's got black on top of its head and that black dot, which differentiate it from Bombus morrisoni or Morrison's bumblebee. And then here's a picture of its face. So we can see the black hairs on the top of its head here. And then we can also see this long cheek. And again, you may not be able to tell that that's long just by looking at it because you may not have looked at enough bumblebee cheeks like me. But when we compare it to Bombus morrisoni and look by them side by side, you can tell the difference pretty dramatically here, where we have a nice short cheek on the right of morrisoni and a really long cheek here on the left. So pretty distinct differences that really helps to differentiate those two species from each other. The next species that I'm going to teach you a little bit how to ID here is the Western bumblebee, or Bombus occidentalis. This species is mostly what we're looking for to identify this species is those bright snow white hairs that you'll find at the back of its abdomen. There's no other species that has these snow white hairs as prominently on the back of its abdomen in our region. And if you see a species like that, it's most likely Bombus occidentalis. In addition to this, the females of this species usually have a black vertex. So the top of their head here is black and their face is usually black. There are often yellow hairs mixed in, but they do usually have a majority of black hairs in there. There are, as you can see from this color pattern diagram, there are a lot of different color patterns for this species. And the further south you get in our region and the further west, the more likely you are to encounter one of these that has a paler or more yellow patterning to the back of its abdomen. And this is one of the reasons why getting a photo of the cheek length for this species is so important. It can't just be the back of the abdomen, because there are different color patterns and that white isn't always going to be distinguishing. This color pattern here is what you'll find in the Rocky Mountains of Idaho at higher elevations. It'll have that yellow stripe on T3 there. And sometimes you'll find some intermediators here, but mostly what we're looking for, and the majority of individuals will have that snow white observation, or as we see in that color pattern diagram there. So again, for this species, we need a photo that shows this short cheek, and you can see the the short cheek here, just like Morrison's bumblebee. It's got a really short cheek, and getting that photo is really helpful in being diagnostic. And then the back of the abdomen, we're looking for white, but having a photo that peels those wings apart so that we can see all 6 segments on the females is really, really important. And so getting that photo so that we can see what those hairs look like all the way at the back of the abdomen is also very important. In this species, we have found, again, throughout a lot of the Pacific Northwest to date, although at fairly low abundances historically, but this is where we should be looking for these species. Would also love to continue looking for the species up and down the Coast Range. It would be really fun to re-find this species in some of those areas where it hasn't been detected in a long time. And then the next species, which is actually also a lookalike for the Western bumblebee, is Bombus franklini. Franklin's bumblebee is a proposed endangered species. It unfortunately has not been seen since 2006. Was the last time that a single individual was observed by Robin Thorpe. And so search efforts for this species are going to be incredibly important. And important for me to say that I've never seen this species in the wild. So everything I'm telling you about how to identify is stuff that I've gathered from other resources and not stuff that I've sort of learned on my own. But the main things that we're looking for with this species are on the back of its abdomen, similar to Occidentalis. It's going to have white hairs, but not at the same number of them, and not the same bright snow white hairs. These are going to be paler, and they're going to almost look like 2 spots rather than sort of a band of white there at the back of the abdomen. The other really unique feature that this species has that no other species has is this horseshoe shape of yellow on its thorax. So it kind of looks like it was half yellow, and then someone punched that black hole out of there. So that creates this horseshoe shape. I've not seen that in any other species of bumblebee anywhere in North America. So this is a very unique feature of this bee and something that we should be looking for. So that's the other thing. And it doesn't show up in this color pattern diagram either, but it is the feature that is talked about often. What photo should you take of this species? Whatever photo you can get. We just want to document that it's still out there. So any effort to find photos of this would be great, but this species also has a short cheek. So getting a photo of the cheek length would be great. And then also the top of the thorax, so that we can see that unique horseshoe shape that you can see here. And then a photo that shows the back of the abdomen, including T5 and 6, are going to help us see if those white spots are there. Where to look for this species is in a pretty narrow range from Mount Shasta to Roseburg, basically. That corridor is the only place that we found it. So those are where we should be looking for this species, and it would be great to find it sometime over the next 3 years. Last species we're going to talk about is Bombus sucklei. This is a cuckoo bumblebee, but the main features that we're going to look at with this species, it has a black on the top of its head. It has that no corbicula on its hind leg because it's a cuckoo bumblebee. And then sometimes we're going to look at these features or the banding pattern on the back of its abdomen as well. So with this species, key photos to take, we need to see a picture of that hind leg to know that it's a cuckoo bumblebee. We want to be able to see a photo of the head, which is also going to show us the top of the head, make sure that it's black, seeing the color patterns on the abdomen. And then also, if you can, take a photo of the last abdominal segment and take the picture from the top. This will actually help for our males and females of this species. For the females, you'll see that the keels of the sternal segment actually stick out to the sides here, as you can see in this photo here. And that's really diagnostic for this species. It helps us determine that it's sucklei versus something else. And then the reason that we would take this picture in a male is one of the close lookalikes for this is going to be Bombus flavidus, which is going to have red hairs or pale orange hairs on the back of its on T7 there, whereas this species is going to have black hairs. The males will have black hairs there. So It's important to get that photo for males as well, and ideally also the side of the thorax. So those are the things we're going to look at for those species. We've not yet detected this species in the Pacific Northwest, but you know to look where we found the Western bumblebee. And so lastly, the two lookalike species for Sucklei are going to be insularis. The main differences here for the females is we've got yellow above the antennae on the face and on the top of the head. For Bombus flavidus, which is the other cuckoo bumblebee, we're also going to have yellow on the top of the head. And remember, Sucklei had black on the top of its head. So that's going to be a really good indicator. And then also with Bombus flavidus, it has this really unique part of its body in that it's strongly recurved underneath. And S6 sticks out past T6. So the sternal segment sticks out beyond the tergal segment. And that's another reason to get that top-down photo of the last abdominal segment if you can. It helps us determine whether it's Bombus sucklei or Bombus flavidus. With that, I will just say another resource that we've made available to you is this color pattern diagram that is available on our website. And we encourage you to bring it with you out in the field. And Joel would like me to remind you all that there's a lot of information on here beyond just the color groupings. So what we've done here is we've grouped these species by the cuckoo bumblebees are here and the striped bumblebees are here. These are the bumblebees that might have red on them. And these are bumblebees that would have white on them. And then these are our black-tailed bumblebees where black goes all the way to the back of the abdomen. And the different features that are really worth looking at here are things like we've talked about cloudy hairs or an intermix of yellow and black hairs. Those actually show up on these color patterns. So you can see with Bombus melanopygus and Bombus mixtus, they're both going to have an intermix of black and yellow hairs at the front of the thorax, and that's something you can look for. Bombus flavifrons has almost all intermixed hairs on its, or the females do, on its thorax. Same with Bombus sitkensis. It's going to have a lot of intermixing of black and yellow. So even the small little micro portions within these segments are meaningful. These are cartoons, but every little piece here means something. Like you'll see that notch in Bombus van Dijkii on T3 there. There'll be a notch, and sometimes it's completely separated across. Same thing with Bombus bifarius and these cuckoo bumblebees. So all the little features that you see in these diagrams are meaningful. There's a lot of information on there, and we encourage you to use these as you're trying to identify the species that you're finding in your areas. But we generally use these color groupings here to help start you. The last thing I'll say is in past years, I've done an entire introduction to every species in the Pacific Northwest and every species that you see on this sheet. We don't have time for that today, but that recording is available on our website and on the YouTube, on the Xerces YouTube channel. So if you want to dive deeper into how to identify all of these, I definitely encourage you to go watch that. It's about an hour and 15 minutes to go through all of the species. But I encourage you to go spend some time looking at those resources and letting me introduce you to all of those species. With that, my mouth is dry. I don't have anything else to say. Well, that's not true. I have lots I could say still, but I'm gonna stop because we said we were gonna stop at 4 o'clock. So I'm gonna respect everybody's Saturday. I'm gonna say thank you so much for spending 4 hours with us today. I can't tell you how meaningful it is to me that you would do this and join us. And please, at this point, I consider you a trained participant in this workshop or in this project. You're welcome to go out and conduct surveys. The survey season officially begins June 1st, but please feel free to go out and do some surveys on your own to practice near your home, and then head out and have a great summer. I've found this is a great way to travel around a beautiful part of the world and look for bumblebees, which is an amazing thing that we get to do as part of this project. We will, once these are posted on the website, we will follow up with you and send you an email and let you know that they're available for you to download and view and share with all your friends. As you leave this presentation today, you will be taken to, there'll be a link for you to fill out an evaluation form. If you would please take some time and fill that evaluation form out, it really helps us to improve these situations. The last thing I'll say is a lot of people have been asking to help us coordinate working with other volunteers, which is one of the great things about doing these projects in person. We just unfortunately don't have the capacity to do that with COVID right now. We need to still do these remotely, and that's something we lose. We gain things because we're able to reach more people, but we do lose some of that. But that's one of the reasons we've gathered and developed the private Facebook group. So there's a private Facebook group for this page. You can find links to it from our website. And that's where you'll find 500 or so volunteers for this project that are actively engaged there. You can say, hey, I'm trying to do surveys in this grid cell. Does anyone else want to join me? And I know a number of people have connected that way. So please feel free to use that resource for that reason. And connect with other volunteers on that page as well. I think it's a great way to build community and a great way for us to work together over the next 3 years and hopefully beyond. And I'm happy to stay on for a couple minutes and answer any questions if they come up. But if they don't, then we'll just say goodbye and thank you very much. So panelists, I don't know if there's any pertinent questions, but I'm happy to stick on for a couple minutes and answer them if there are.
No, I think people were a little unsure because we didn't get to watch the full video about how to, choose vials and types of nets to use and how to catch a bee and how to transfer it. So that's very understandable. We will make sure to reach out particularly to all the participants of today's workshop with an email that will have links to these videos. We do have a couple other recorded sessions on how to net a bee, how to transfer one. We will provide you an email with those videos. Just want you all to be assured that this is not as hard as it sounds. Catching a bee, they're way easier to catch than a bumblebee or a butterfly. And the first time you see one transferred from a net to a vial, you're going to go, oh, that's not as scary as I thought it was going to be. It's really not. Unfortunately, this is the worst part of COVID, is that we just can't show you in person how easy that is. So please don't be afraid to grab a net and try it for yourself. If you're in Idaho, we are going to have some in-person field days with our regional diversity biologists. And if you would like to participate in one of those, reach out to me. If you haven't got an email from me already, I'll be happy to put you in touch with the proper people. And make use of the Facebook group. Rich mentioned that. And then finally, I'm not sure if we ever introduced the participants handbook, but Rich has put a lot of time into answering a lot of these questions. A lot of the things that we went through today is in the participants handbook. You probably want to print a copy of that and take it with you in the field doing these surveys. It can answer a lot of questions. So with that, that kind of ends my comments, and I just appreciate everybody that stuck with us to the bitter end. And thank you for participating so far. And I really thank you for turning in your data this summer.
I just put a link to that survey video again at the bottom of the chat there. And then also to the handbook, or a page where you can find the handbook. So hopefully you'll find those useful. And like Joel said, we'll send a follow-up email with this. And when we publish this video to the website, we'll insert the real video in there. So you'll get to actually just see the real video as you watch this whole thing. So it won't be like the choppy version. We'll just splice that part out and put the real video in, and then everybody can get what they need. So with that, I'm going to say goodbye. Thank you, everybody, for joining us on this Saturday afternoon, and have a great time Bumblebee watching this summer. I appreciate you more than you possibly know, and look for information from us in the near future. Thanks a lot.
Thanks, everybody.